Hello? Hello? Can you hear me? Hello? I can't hear you. Okay, I'm fine. Okay. Hello. I only could see a picture of Kelly. I can't see you all.
Hi, this is Matt. Can you hear me?
Matt, can you hear me?
Yes, Rosalba, I can hear you.
I'm just trying to test with the speakers. Can you hear me still?
Say again?
Can you hear me?
Yes.
Okay. Hello.
Hi, this is Matt.
Okay, it's Kelly. So I'm going
Hey,
to
Kelly.
open up my video there. And I know we have, is Sal in? Nope, I don't think Sal. Rosalba, you're in?
Yes, I'm here.
Okay, terrific. And I know we have one other participant who's just still on standby right now, but that's okay. We're going to get started shortly. So for our very early bird participant there, thank you. But we'll be getting started at the top of the hour. We're just signing in and making sure that everything is working appropriately. Okay. All right. So I'm going to put in my earbuds as well. And what I'm going to do, excuse me. Okay, there we go. What I'm actually going to do is a, very brief introduction and actually really just turn it over to you to have both of you kind of introduce yourselves a little bit and talk a little bit about your backgrounds, and then we'll get started. And you are in co-host mode, so you should be able to share your screens.
Okay, let me try a quick screen share just to see if that works. Can you see my screen?
Yes, we can.
Awesome. Rosalba, why don't you give it a try?
Yep.
So we're seeing your name.
Okay.
And we'll see your screen.
Can you see
Great.
my screen
Yep.
now? So yeah, so just as a reminder, if you can share the Earth Minute video.
Yes,
when I
I've got
get
those.
there, because yeah, we're gonna have to switch sharing the screen. That's it.
Yep, I got it.
All right, we'll give just a couple minutes. I'll start to allow some folks to come in. Bear with me. Okay. I'll open this up in just a few minutes. And it looks like we have a great turnout showing up, so this is terrific. I'm just sending a note to everybody to tell them we're going to be starting shortly, so thank them. So okay. And after I introduce the two of you, then I'm going to go ahead and stop my video recording just so I would make sure we don't slow anything down. All right, we have roughly 4 minutes, but I'm going to switch it over, just give it 2 more minutes, and then I'll admit everyone. We'll just pause for a moment to allow people to join. I want to welcome everyone. Just bear with me. We're going to get started in a moment. If I could ask individuals, just because we don't want to have a delay, but we still want to see your faces during the question and answer period, could we please ask you to stop your videos? Because it just seems that Zoom was a little slow earlier today. So if you'll stop your videos, that would be terrific. And we're going to get started in just a moment. We're just asking everyone to bear with me. And again, if you could just stop sharing your videos as well. All right. And I want to thank everyone for joining and participating in this webinar today. I also want to thank everyone for switching over. Zoom webinars today was down a little bit earlier. And so we decided that we needed to quickly pivot. And we ended up making that pivot to Zoom messaging. And I think that has worked, and we still have people that are joining, so this is wonderful. So again, we're going to go ahead. We're going to get started, and I will be putting all of the videos, as I said earlier. I'm going to be putting those videos where we don't see you at this time, but during the Q&A, you have a question to ask, please feel free if you would like to resume with your video, and you can ask that question. So, and if there's any questions throughout, don't hesitate to reach out to myself, Kelly Wells. You can always just send me a message too. So with that, I would like to go ahead and begin by introducing our very prestigious speakers today. We have Matthew Pearce, who's a NASA Education Program Specialist, and he is coming to us from the Goddard Space Flight Center Office of STEM Engagement. And we have Rosalba Giarratano, who is a Pathways intern. And I'm really excited. NASA has so many resources that are available there, and just a wealth of knowledge. And it's just such an honor and privilege to both have Matthew as well as Rosalba with us, and especially of all times this week, a week where we have the space shuttle launching, and just this whole new endeavor that we're on. So again, it's just a real honor to be a part of this. So without further ado, we're not here to hear from me, we're here to hear from them. I want to go ahead and turn this over to both Matthew and Rosalba.
Thanks, Kelly. Can you give me a thumbs up if you can hear me? All right. Hey, everyone. Thank you for joining us today. And a special thanks to Kelly for bringing us together and the amazing work she's done in the STEM Leadership Alliance. And especially thank you to all the participants online who are taking time out of your already busy day to join yet another webinar or a Zoom call or a Zoom conference, as I know we're all adapting to this new environment. My name is Matt Pearce, and it's a real privilege to have an opportunity to meet all of you today. As a brief introduction of myself, my role with NASA is to lead NASA's STEM education efforts at the Goddard Institute for Space Studies in New York to improve STEM education for all formal and informal education groups on state, local, and federal, and national and international levels. My career history is I've had over 20 years in the classroom. I led a lot of initiatives to bring distance learning to the forefront of education. I opened one of the first online high schools back in the late 90s. I've also opened up new brick and mortar schools and science departments, and have simultaneously kind of walked a science profession and also an education profession, which is ultimately what led me to NASA, which is a wonderful group that I hope you'll consider engaging. So our goal today is to provide a quick overview of my office in New York City and try to get some connections with you. And Rosalba is also going to provide you a brief orientation to a variety of education resources that we provide as an introduction. We have a vast portfolio of content that we think might assist you in distance learning. I did receive some of the earlier questions that were sent in, and I'm really hoping to have a robust discussion at the end about how we can improve distance learning for everyone. So I'd like to hand it over to Rosalba to introduce herself, and then we will begin with the presentations.
Hello, everyone. Can you hear me?
Yes.
Yeah. My name is Rosalba Giarratano. I'm a Pathways intern. Like Matt, I also support NASA Goddard Space Flight Center Office of STEM Engagement at the Goddard Institute for Space Studies in New York City. I have had the very good luck to be in different NASA centers. So I have also worked at NASA Kennedy Space Center and NASA Langley Research Center. So I really love working for NASA. I'm super happy to be here with you today to share some of NASA educational resources that hopefully you will be able to incorporate into the remote learning environment. Thank you.
Awesome. Thanks, Rosalba. All right, so I'm going to do a screen share. Rosalba and I will be bouncing our screens back and forth, so apologies if we get any delays or frozen screens, and appreciate your patience as we work through the distance environment. But at this point, you should see my screen. Rosalba, can you confirm?
I can see your screen.
Okay, awesome. And again, hoping to plant a lot of seeds and have some robust discussion at the end. Again, Rosalba and I work at the Goddard Institute for Space Studies in New York City and Manhattan, surprisingly above the diner that was featured in Seinfeld. So that's a lot of fun when we can actually physically walk into the office. The reason I start with this slide is I think it encapsulates some of the great work our scientists do at GISS. And generally speaking, these are a group of fascinating, brilliant scientists that work with all of NASA, but are focused at GISS, that study the Earth from the bottom of the ocean to the very top of the atmosphere, and look at all the variables in between to try and identify how our planet is changing and what's happening with climate change. So in the resources you're going to see today, we're going to have a degree of focus on resources that relate to GISS, and with the intention of trying to illustrate some of our capacities. But if you have unique content interest in mind, perhaps you want to hear about Artemis, or you want to hear about a Mars rover, or you want to look at aerospace, we can always work with you individually to get you some resources to those needs. So I wanted to give a real brief snapshot of NASA centers. We have 10 centers around the country. Many of our centers are joined with university and other research labs. The Goddard Institute for Space Studies, which I'll refer to as GISS, is very connected with Columbia University, Lamont Doherty Earth Observatory, and the Earth Institute. But it's a really awesome network to work in, and we have education teams at every center that can bring unique capacity to distance learning. Our campuses, we actually have 6 campuses right now. Our largest one is in Greenbelt, which is just north of Washington, D.C. It's our largest center. There's over 10,000 scientists and engineers there. And we've built all kinds of amazing things like the Hubble telescope and Global Precipitation Mission, and support the ISS, the International Space Station, their communications, and so on. GISS, the one in the middle, is obviously the best one because Rosalba and I are there. But all of our teams at each one of these centers are epic and amazing in all the work they do. We even have a launch facility out of Wallops Island. And often we work with teachers and students and schools to launch sounding rockets and CubeSat payloads, all with the goal of inspiring the next generation. Again, GISS is really focused on remote sensing of aerosols and clouds. So very often we work with teachers and students to tap into our satellites and get some of that immediate data that's teaching us lessons about the climate, and then utilizing that in the classroom. We also take a deep look at global climate modeling and climate impacts, trying to identify in the different areas of the world how the climate is changing and what impacts it's having on things like groundwater supply or lakes drying up or temperature changes and so on. And then what's really fun is we take those lessons learned to identify planetary climates and trying to find the next habitable Earth. Our director, Dr. Gavin Schmidt, leads GIS, and I strongly encourage you
Matt,
to view.
I'm just going to, Matt, I'm sorry to interrupt.
Sure.
There was somebody that was just having, okay, so others can hear. So the person that was having trouble, just maybe try recalling in. All right, thank you for that, and I do apologize.
Okay, should I stop my video?
Nope, you're totally fine. Continue because others can hear you and everything else is working.
Okay, all right, we'll keep moving forward. So yes, again, I would encourage you to take a look at Gavin's TED Talk. If you Google his name and TED Talk is, that'll pop right up. And he does a great job of communicating what's happening with climate change and the process by which we use models to analyze that. As I know some of you on the call are science teachers, and maybe you heard of a science or an educator called John Dewey. What's fun for me is he actually used to live in the building where GIS is now housed, and he's a real leader in what is now STEM education. So a quick snapshot of Goddard, some of the questions I received, one in particular was like, what's some of the coolest things going on at Goddard? And Rosalba and I were talking about this question earlier, and I couldn't think of just one cool thing that's going on there, but we have our footprint in just about every mission that goes on with NASA. We're definitely supporting our attempted launch yesterday with SpaceX, which we'll end up doing this Saturday. We have hundreds and hundreds of technology spin-offs that go out into the economy to support a whole variety of different medical advances. Recently, some of our teams contributed to a new design on a ventilator to respond to COVID. We made the Hubble telescope, and we'll be launching next year the James Webb telescope, which is about the size of a tennis court. I'm sure you can imagine the engineering challenges of that while packing that into a nose cone. From an education perspective, the NASA Office of STEM Engagement vision and mission focus on immersing the public in NASA's work, enhancing STEM literacy, and inspiring the next generation to explore. What we want to do through our education platforms and with both teachers and students and citizen scientists is to get the public to contribute to our work. And we do that in a variety of ways. I run a whole variety of different intern and fellowship programs, often which that have deliverables that are similar to what's on the screen. You can see this was one of my internship teams that was trying to assess ancient Earth, which is commonly referred to as snowball Earth, and then using those lessons learned to look out into the universe and find Earth-like planets. If you or your students or friends are interested in applying to NASA's internship program, they can go to intern.nasa.gov this summer. Across all of NASA, we're going to launch about 3,000 interns into what's now a virtual internship program. Typically, we have them on center. But if you have a student that's interested in coming to work with us, we take high school students, undergrads, grad students, and even teachers if they're interested in coming to learn to work with us. One of the programs I run is the Climate Change Research Initiative. And this is where we take a vertical team of a high school, an undergrad, a grad student, and a STEM teacher and work all directly under a NASA scientist to produce lesson plans and scientific research papers and scientific posters that we end up presenting at national and international conferences. So I always love a few pictures of all of our former interns. On the top left is Gavin Schmidt, who I mentioned earlier. This is a cohort from last summer. Again, teachers, grad students, high school students, and so on. As you're thinking about my office and what we can do for you, I want you to think about that we customize educator professional development experiences for organizations. And we're happy to talk with you at another time about developing a online EPD or hopefully a face-to-face institute, depending on where you are. We often work with many partners to come together and also leverage assets to create unique learning opportunities for teachers. And this is, again, is just another example of some of the awesome teachers I've had the privilege of working with, where they get to come in, and in the top right-hand corner, you can see where we have a group of teachers hearing from one of our lead cloud scientists. This is Bastian, and he's an expert on clouds. Down on the bottom left, I was able to take a team of my teachers down to meet our director at Goddard, Chris DeLees. And we often work with museums as well to bring together both formal and informal educators into a cooperative environment. Also create any number of STEM engagement activities that are experiential learning opportunities to connect learners to NASA. And we do that through a variety of STEM challenges, online learning opportunities. Right now there's a COVID challenge where we're providing access and data out to students and communities to try and come up with solutions for those issues. But we really are driven to improve STEM education and distance learning across all levels of education. And as we move forward, I want you to think about how we try to engage in capacity building. I often work with networks and communities to provide an all hands on deck approach to really inspiring and engaging the next generation to explore. This is a teacher in me, I think, that loves this picture. I think it says a lot of who we are and what we're trying to do. On the right is Robonaut. This is a robot on the space station. We are trying to hand off the legacy of NASA to all of our students and children and next generation. So real quick look at some missions that might get you inspired. This is a quick look at our Earth observation fleet. You can see the International Space Station. IceSat-2 is really cool. It's measuring all of the ice caps and how ice is changing on the planet. Your students and you and anyone can access that data to get a real deep look at how our Earth is changing. Quick snapshot of James Webb. Again, this is the mirror itself. It's 6.6 meters high and wide. And that's going to be a revolutionary look into the universe. It's going to completely change our perception of the galaxy. We are still planning on going to Mars and are building a new space launch system to do that, but also take us to the moon. And this is a quick snapshot of our entire science fleet that is currently operating or being built. And you can see that we've got a lot of amazing instruments out around the sun, certainly around the Earth, the moon, Mars, Jupiter, and looking out into the galaxy. You may have heard about the Artemis mission, and the administration has set a goal that we're going to put the first woman and the next man on the moon by 2024. These next couple of slides are just some snapshots of what that's going to look like. We're going to have a few missions to get us out there and get us the lessons learned before we send a crew on EM3. This is the rocket that's going to take us there. It's the biggest, baddest rocket ever built. It's called the SLS for Space Launch System, and Orion is the capsule that's going to get us there. We're also building a new little mini space station around the moon that ourselves and commercial crew partners will dock to as we go to the back to the moon. So I wanted to show you a quick video of what that's going to look like.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible. Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket, the Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
That can support humans from launch
through deep space and return safely back to Earth.
For this, we built Orion.
this is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources, we're currently developing an entirely new approach to landing and operating on the moon. Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable, that can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will bounce between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water, and separating oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system. This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and onto Mars to seek knowledge and understanding, and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going. We are going. We're going.
All right, so very, very exciting things happening at NASA, and we hope that you'll join us on the Artemis mission. I also hope you're signing up for the STEM Leadership Alliance Summit. You will have an opportunity to meet many of our leaders that are supporting the Artemis mission, including Mike Kincaid, who leads our STEM engagement office. You're also going to get a chance to meet Barbara Morgan, one of my colleagues. She was in the Educator astronaut program, and quite a few other NASA representatives. But without further ado, I'd like to pause and hand it over to Rosalba, who is going to show you some specific resources that you can also share with your students, and hopefully will engage opportunistically in some distance learning activities. So Rosalba, take it away.
Thank you, Matt. I'm sharing my screen now. Can you see my screen now?
Yes.
Okay. So I'm going to first talk to you about why I chose the resources that I chose to share with you today. If you have ever browsed for NASA educational resources, you may have found that there are many, many resources, and we have limited time. So I had to choose some of them. So I will talk to you about Earth Minute, Earth Now, BEST, Earth Observatory Kits, Worldview, RSET, and then I will briefly mention some other resources. So, like Matt was talking, at the Goddard Institute for Space Studies, a key objective is the research that has to do with the prediction of atmospheric and climate changes. So many of our scientists at GIS rely a lot on data that comes from satellite. So I decided to choose some of the resources that have to do with Earth science, with climate change, and with NASA satellite missions. So the first resource that I want to share with you is called Earth Minute. This is a whiteboard animation series explaining Earth science topics. It is a very, very cool way to introduce a topic and to capture students' attention. Like the name says, every video in this series is about 1 minute long. And the topics include aerosols, clouds, sea level rise, greenhouse gases, climate change, and more. So I'm going to have to stop sharing so that Matt can share one of these videos for you to have an idea of what this series looks like.
When you think of NASA, you probably think of astronauts, satellites, Mars rovers, and telescopes that study distant
Is that coming through?
Yes.
planets and far-off galaxies. So why does NASA as a space agency study Earth? Because it's a planet too. And there are a lot of advantages to monitoring the only home we currently have, from space. Just 3 years after the space age began, NASA launched the first satellite to monitor Earth's weather. It was the beginning of a revolution in weather forecasting and laid the foundation for the global study of Earth. Today, NASA's fleet of Earth-observing satellites is essential to helping us understand how our planet works. We're trying to answer some very big questions. How is Earth changing? What's causing these changes? And what does the future hold? The answers are critical to human life and civilization as we know it. Adding to what we learn from satellites, NASA also makes regional observations from airplanes and ships. Our scientists collect even more data on the ground, and others use computers to model what's happening now and in the future with the land, ocean, and atmosphere. Altogether, it's called Earth System Science, and NASA is a global leader in the field. Best of all, NASA shares what it learns with researchers and agencies throughout the world. Because when it comes to understanding Earth, space is the place to really know a planet. And that's exactly where NASA is.
All right, back
Thank
to you,
you,
Rosalba.
Matt. Yeah, I'm going to share my screen again. Okay, so that was Earth Minute. So that's just an introductory video explaining why NASA studies Earth. But like I said before, there are videos explaining different topics like clouds and sea level rise, climate change, and so on. If you need closed captioning, these videos can be accessed through YouTube. And also on the Earth Minute website, you can download the videos, and some of them are available with subtitles in Spanish. And also, I forgot to mention, we will distribute these slides, and at the end of the slides, I have listed all the links to these resources, so you don't have to worry about remembering how to get to all the resources. The next thing I want to talk about is Earth Now. This is a really, really cool app. So with Earth Now, you and your students can monitor our planet's vital signs, from sea level, height to carbon dioxide concentration, ozone, volcanic eruptions, forest fires, and more. With this tool, you can also learn about NASA missions, about the satellites that are involved in those missions, and the instruments on each satellite. You can access this app online, or you can also download it on your phone or a tablet. So I'm going to show you how it looks like. Can you see Earth Now, Matt?
Yes.
Okay. So as you can see, this app will show you the planet and the satellites that are orbiting our planet to take measurements. So this is a very, very interactive app. So you can spin the globe, you can move it, you can also zoom in or zoom out. And with these satellites, if you go to the bottom right-hand corner, you're going to see an icon that looks like a satellite. If you click on that, you can change the time rate at which the satellites are orbiting. So you can speed it up. I know there may be a lag from where when you see the visuals, so I'm trying to go a little bit more slowly. So you can speed up the satellite time rate or you can slow it down. And there's also this button also on the lower right-hand corner where you can see the words real time. So if you click on that, it will show you exactly where the satellites are in real time and how they're moving, orbiting Earth. There's another icon also on the bottom right-hand corner. It's like a light bulb. So if you click on that, you can turn off the sunlight. So that would indicate that on this part of Earth, it's nighttime. And this part is daytime. And you can turn on the sunlight again by clicking on the icon again. Another feature here is that you can select any of these satellites and find information and also play a little bit with the satellite. So for example, let's say that I want to look at SMAP. So I'm going to click on the name of the satellite. It takes a few seconds to load. And then I can look at that satellite. I can move it to examine different parts of it.
We're
I can
lagging
also
just
zoom
a little bit.
in. It's lagging?
Yeah, we're just now getting to SMAP. We can see the reflector array.
Can you see it now?
Yes.
Okay. And then on the lower left corner, you can find more information about that satellite. So you click on the arrow and it will tell you, for instance, that this satellite has been in orbit for 5 years and 118 days, what launch vehicle was used, and then it will give you more information about that mission. Another feature that you have is the vital signs on the upper right-hand corner. So if you click on that, you will find all these key indicators of our planet's health, and you can look into that. So you can see these visuals with data that has been taken by satellites that has to do with their temperature, with carbon dioxide, with carbon monoxide, and so on. So let's say that I want to look at the air temperature. So I would just click on that. And here I have a visual of the air temperature measurements. So again, I can rotate the planet. I can move to different areas of interest. I can also zoom in or out. Here on the bottom, I have the scale, and I can also switch between units. So I can switch between degrees Fahrenheit and Celsius. And I can see that these measurements come from the Aqua satellite. So once again, if I want to have more information about that satellite, I can just click on the name of the satellite. It will take a few seconds to load. And then it will show me the satellite. I can play with it a little bit. And again, on the lower left corner, I can find more information about the satellite. The other thing that I have is that it will also list the instruments that are aboard of that satellite. So if I want to learn more about the specific instruments, I can also click on any of them, and that will take me to the web page that is giving me information about that instrument. So for instance, let's say that I want to learn more about the MODIS instrument. So I will click on that, and that will take me to the MODIS web page. So here I can learn more about the instrument, but I can even also download data that has been taken by that satellite. I can also browse missions on this app. So for instance, let's say that I want to learn more about the International Space Station. So I can click on that. And I can also play with that and learn more about it. So a very, very cool app. And again, you can also download it on a phone or a tablet. So let me go back to the presentation. So that's Earth now. So hopefully with that application, you can pick your students' interest. Maybe you can have them work in teams. Maybe you can assign one mission to each student and then they can share what they have learned. Or another idea is that you can have your students explore these satellites to get inspired so that then they can think about designing their own satellite, which brings me to the next resource that I want to share with you. So this resource is called BEST. It stands for Beginning Engineering, Science, and Technology. And so basically these are activity guides. There are 3 of them divided by grade bands. So the first one is for kindergarten to 2nd grade. Then there's one for 3rd to 5th grade. And then the last one is for 6th to 8th grade. And so these activities introduce students to the principles of engineering. And in order for the students to create their designs, you have to use only very common items. So it's very easy to do at home. Generally, you just need household items. So I want to highlight one of the activities, again, that is related to the satellites. So this one is from the activity guide for the younger students. But you can find a similar activity for older students, and of course it starts getting more complicated. This one is very easy. So you have students thinking about their own satellite, and so they have to use buttons of different colors and shapes to represent different instruments. So again, maybe they were inspired after using Earth Now, and they can think about some of the instruments that they want to use on their satellite. The other part of the engineering challenge is that they have to be able to build this satellite, and then they have to drop it from above their head without any pieces falling off. So that makes it a lot of fun, but it also gets them thinking again about this engineering design process in which maybe it doesn't work at the first time, and so then they have to try again and make adjustments. And also on the right of my screen, you can see how you can integrate math into the activity. So you tell the students, well, for each instrument that you want to have on your satellite, you're going to require a certain amount of solar cells so that they can function, so that you can power the instruments. And so you can assign values. So maybe the camera will take 3 solar cells, and the heat sensor will take 1 solar cell. So then the students have to determine how many cells they will need in total. Again, this is for the youngest students, but you can find this activity also for upper grades with more challenging problems. The next resource that I want to share about is Earth Observatory Kids. So this is basically an electronic magazine. This one is written for audiences ages 9 to 14. You can read it online or you can download it as a PDF. And so each issue has articles about a specific Earth science topic, and then they explain what satellite missions are measuring a specific aspect of that topic. And usually there is also a do-it-yourself kind of project included. And again, these are meant to be done at home. So they just need very, very basic, like common household items. So the students can do activities and experiments and learn more about Earth science. So another very, very good resource. The next resource is Worldview. This one is more suitable for older students. So I would say maybe upper middle school and high school. This application lets you interact with a lot of global full resolution satellite imagery layers. And also you can download the data that is associated to those satellite images. It is updated daily and available within 3 hours of observation. So that means that you are really looking at the world as it is now. And this application is not just used by students and teachers. It is actually used by professionals to support application areas such as wildfire management, air quality measurements, and flood monitoring. So I'm going to go to Worldview to show you an example of how it works. Can you see it now, Matt?
Yes.
Okay. So when you first go into Worldview, it will give you this page where you can look at some significant events, for example, the fires in Australia or Hurricane Dorian. So you can look into those stories if you're interested. You can also look at those stories later. For now, I'm just going to close that window so that I can show you how you can interact with Worldview. So as you can see, you will get a world map. These black bands that you see are normal. Those are just parts where there is a hardware obstruction on the instrument on the satellite, so there are some gaps. They call that row anomaly. But you have this world map, and then on the left, you have the layers that you can add to the map. So you will see that you can place labels on the map. You can just click on the icon that looks like an eye, and then that will show the labels for the countries and oceans and so on. You can also add borders, roads, coastlines, and then you can add layers of the actual data from the satellite. So for this exercise, I am going to focus on New York, also because the Goddard Institute for Space Studies is in New York City. So I'm going to go to New York. So you can, as you can see, you can zoom in, zoom out. And then I figured that for this example, I would show you something that is very timely. As you can see here, there are many, many parameters that you can choose from. So this is all the data that you can explore. But I thought I would show you an example that has to do with air quality. So as you know, as a result of the COVID-19 situation and the shelter-in-place restrictions, we have seen a significant reduction in air pollution, not just in the United States, but across the globe, of course, and so especially in major metropolitan areas. So I figured I would show you how we can look at one of these parameters. So I'm going to go to air quality, and then I am going to choose the nitrogen dioxide layer, because that is one of the air pollutants that is regulated by the EPA, and also because that's one of the pollutants that generates yet another pollutant, which is ozone. So let's look at nitrogen dioxide. Once I click on that, I will get information about the sources that I can choose from. In this case, I'm going to choose the data from the satellite Orion, and specifically the OMI instrument. OMI stands for Ozone Monitoring Instrument. So I'm going to select that, nitrogen dioxide, and then I am going to exit that. And on the bottom left corner, I am going to select the date for which I want to see the data. So in this case, I am going to select January, let's say January 15. You can enter the data like that. Because before, right, in January, there were no restrictions, everything was normal, so I'm going to look into that. And then I am going to also look at, I'm going to try to make a comparison. I'm really not seeing much information with January. Let me see with February, maybe. Then I can, with Worldview, I can compare with another date. So to do that, I just have to click on Start Comparison, also here on the left. And so on the left side of my screen, I am going to have the first date that I selected. Oh, and by the way, if you see now that the borders and the labels have been blocked by the nitrogen dioxide, you can fix that on the left by moving your layer of nitrogen dioxide down. You just drag it down. That way you can see the layers, the labels again. So then, when I start the comparison, on the right, now I have a different date. I can select a different date to make a comparison. So I'm going to select May on the lower left corner. I'm going to say May 15. And I'm going to switch. For some reason, it's not really showing much information on February. So let me see if March is better. And then on the screen, you can see that I have a bar. So I can go ahead and look at the comparison between one layer and the other, between one date and the other. I'm going to zoom a little bit more. And so you can see the difference here in the colors of the amounts of nitrogen dioxide in one month and the other. It is taking forever to refresh on my screen, but that gives you an idea of what you can do with Worldview. The other cool thing that you can do with Worldview is that you can share your map. So for instance, if you assign your students to do some investigation and make a comparison, that you can have them share their map with you. So if you click on the upper right-hand corner, you can get a link of your map. You can also shorten it. And you can share it on social media, but you can also simply mail it. So you can copy the link. That's a link that is permanent of the map that you created. So I can go to another web page and paste that link, and that will give me my map. And the same map that I had created before. And so that's Worldview, and I know that we're going to run out of time. So let me go back to the presentation. There's another resource that I want to share with you. It's RSET. It's also known as the Applied Remote Sensing Training. So this is a website where you can find webinars, information about webinars, and also online trainings that are asynchronous. So you can just go ahead and you just register. They're always free. You just register, and then you can attend these webinars or the asynchronous online training whenever you want. And the webinars sometimes are also available in Spanish. And they have topics that go from introductory levels, from the foundations of remote sensing, all the way to advanced topics like how to use, for instance, Earth observations to monitor water budgets and stuff like that. These ones are more suitable for high school students and college students. And also I want to mention, in addition to those Earth Science resources, I just want to quickly mention this resource about the commercial crew. So like Matt was mentioning before and Kelly was mentioning before, yesterday we were scheduled to have the first launch of American astronauts and American rockets to the International Space Station since 2011. That has been postponed, so we're hoping that you will join watching that on Saturday. But I just wanted to point out that there is this resource that has to do with the commercial crew program. So there are engineering design challenges, and there are also some apps. There's a SpaceX simulator. So again, at the end of the slides, there will be links to all these resources. And just also very quickly, some other resources that we want to talk about. So there's the NASA EPDC, which is the Educator Professional Development Collaborative. So that's an effort in collaboration with Texas State University. And so they have professional development webinars and also something called digital badges. So these are models that you can access online about many different topics, Earth, space, and more. And then there's another resource. It's called the Globe Observer. So if some of you are not familiar with the GLOBE program is an international science education program that engages students, teachers, citizen science in data collection about different aspects of our planet. And so you collect the data and then you can submit your data either directly on the GLOBE website or using an app that is called Globe Observer. And so, for example, you can make observations of clouds, and then you submit your observation, and the app will even alert you when there's going to be a satellite that will pass over you, so that you can make the observation at the same time. And if you do that and you use the app to submit your observation, then in a couple of days you will receive an email from NASA with a satellite match. So it will tell you, well, this is what you saw from the ground, and this is what the satellite saw from above. Then we also have the Scientific Visualization Studio that is a Goddard application. So you can go there and look for animations and visualizations that have to do with Earth data, science data. So it is just a cool way, an easier way to understand science topics with those visuals. And we also have My NASA Data. That is a very, very comprehensive website. It has lesson plans, activities, story maps, connections to the GLOBE program, and much more. So if you're just like even looking for lesson plans, there are many, many lesson plans in that site. It's mostly also Earth science. So they have them organized by spheres, by cryosphere, hydrosphere, atmosphere, and so on. And also there is a Climate Kids website, mostly geared towards the youngest kids. So it has videos, articles written in a very kid-friendly way, and games. Also, I want to point out, if you just go to nasa.gov/STEM, you will find a collection of resources for STEM at home. They're organized also by grades, so you will find K to 4, 5 to 8, 9 to 12. There is also NASA at Home, so that's a collection of podcasts, videos, virtual tours. So for instance, there are virtual tours to different NASA centers, to the International Space Station, to Mars, even to exoplanets. And last but not least, I also want to mention NASA Express. So I highly, highly encourage you to sign up for weekly updates at NASA Express. So you will get information about webinars, contests, opportunities both for students and for teachers. So it is a very, very helpful resource. And here I also have Matt's email address and my email address. We do have a learning management system. So Matt will share with you a form that you can fill out if you would like to join our community and our learning management system. And I send announcements and updates weekly as well. And like I said, we're going to share the slides with you. So all the links to all the resources are listed here. Yeah, so that's for me.
Could you just go back briefly to that last slide, just in case if folks wanted to be able to take a screenshot of that?
Yeah, I mean, we can also share the slides with you if you'd like.
Great.
But let me
Yes, and we will send this out to everyone. I know Matt was sharing in the chat all of those amazing resources and links, and we'll be sending that out as well.
Yes.
Yes, it's individuals would like to see it now.
Here it is. Give me just one moment.
While you're loading that, the last link I put in was a link to a Google Doc for you to get us your contact information, and from there we'll extend you an invitation to join a learning management system, and that is constantly updated with new resources, projects, opportunities, different programs we run, mission updates. So I hope you'll sign up for that. We'd like to invite you into it's an asynchronous platform, but it will really keep you in sync with what we're doing.
Terrific. Thank you so much. I know we only have a few minutes. I think there was a lot of information that was shared. If there are any questions at this time, feel free to unmute yourself or to or also resume your video if there's any additional questions. Oh, and sorry, Rosalba, they were asking if you could actually share the next slide. I'm sorry to keep having you go back and forth to that. Thank you.
No, it's fine.
Perfect.
Do you want the previous one or this one? Okay.
No, this one I think is really helpful.
So I've got the question list you sent me, and if certainly somebody has another question, feel free to interrupt or throw in a comment. I did see a lot of questions about key resources, and again, if you sign up for our learning management system, you will get an ongoing blast of all key resources. There are also a variety of questions related to what are some best practices for engaging students in a distance learning environment. And I know that's a real challenge that everyone is facing. In my experience, I found the best opportunity was to kind of approach distance learning also the way we approach the premise of STEM, by breaking down the silos between disciplines and kind of flipping the teaching model to where the students are leading instruction, obviously with guidance related to project-based opportunities. Perhaps you want to suggest to your students that they design a mission to the moon and break them up in various teams. And then they have to do the research and obviously guided and supported by the teacher, but make them part of the instructional process very much like you would a design team. And again, welcome any questions from the group or discussion points.
And even at this time, if there aren't questions or you think of something or you start to go through these resources, please don't hesitate to reach out to the NASA team or to reach out to myself, and I will put you in connection. I think Matt and Rosalba are two of the people that are extremely responsive and really helpful and completely committed to educators just getting information and the tools and resources. And this is some of the best remote learning information that's out there. So I really encourage everyone to spend a little bit of time with this. And again, Matt put his email there, so thank you for that, but we're certainly here to help all of you. So I'd like just to, in closing with this today, I want to thank everyone for joining this. I want to encourage everyone to save the date from July 12th, or excuse me, July 13th to the 16th for the Virtual STEM Leadership Alliance Summit. There'll be more information. You'll be seeing that in the newsletter as well as on social media. And I also have an ask to everyone that's on the call today that we'd like to hear from you. If there's other topics or additional information that you're looking for, we'd be happy to provide that as well. So with that, I just want to again thank everyone. I want to thank both Matt and Rosalba for your participation in this very informative webinar today. And again, just stay tuned. We have another professional development that we'll be looking at on June 17th, and you'll be seeing more information about that. But don't hesitate to reach out. And once again, I want to thank everyone for your participation today.